Yeah.
So can we start?
Mm-hmm.
Yeah. Good evening, one and all. We welcome everyone on second and final day of COALESCE 21, the annual Data Science Summit of Go Institute of Management. We are yet again honored and delighted to have amongst us Mr. Ansgar Koene, Global AI Ethics and Regulatory Leader at EY. He has joined us live from London thanks to the online mode. In EY, he contributes to the work on AI governance, trusted AI frameworks, and AI-related public policy engagement. He is also a senior research fellow at University of Nottingham, where he contributes to the policy impact and public engagement activities of the institute and the Re-Interest and Unbiased projects. Sir chairs the IEEE Computer Society AI Standard Committee and IEEE P7003 Standard for Algorithmic Bias Considerations Working Group. Mr. Ansgar has a multidisciplinary research background, having worked and published on the topics ranging from policy and governance of algorithmic systems, data privacy, AI ethics, AI and computational neuroscience, to experimental human behavior studies. I would also request the participants to drop their questions in the chat box, if any. We will take the questions at the Q&A sessions. We welcome you, sir. The stage is all yours.
Thank you very much, and thank you for this invitation to speak to this audience. It's always great to be able to reach out to a broader audience in various different parts of the world. So I'd like to, I'm going to share my screen now so that I can present some slides for my presentation. So today I wanted to speak about algorithmic bias, and particularly diversity and inclusion questions regarding this. And so what you see here is a result from a survey study that EY did together with Future Society, which was really asking policymakers, so government and other regulatory agencies, as well as companies, what kind of priorities they see when it comes to questions related to ethics or trust-related factors connected to AI. So in blue is the policymakers and in orange is the companies. What we see is something of a disconnect on particular issues, especially on the question around fairness and avoiding of bias. Why is this? So the question of algorithmic discrimination or bias, fairness kind of issues arises as algorithmic systems are being applied to real-world issues where decisions are having impacts on people. Things like who gets hired for a job, applications of AI in assessing whether somebody is eligible for parole, assessments of people's likelihood of being able to qualify for a loan, all kinds of issues that impact people's true lives and their ability to engage with economic, social, or other kinds of aspects. In this space, people have strong concerns as to whether these automated decision-making systems will either introduce new bias or will re-entrench, strengthen existing historical kinds of bias. And this is one of the driving reasons why policymakers are particularly concerned when it comes to the question of bias. Companies overall from that survey study seem to be primarily focused on things where there is existing regulatory drivers where compliance is necessary. So what are reasons why algorithmic systems might exhibit discriminatory kind of behavior? So one clear aspect of this relates to the kind of data that is used for these types of systems, be it data for training a system, if we're talking about something like a machine learning system, or data for validating a system. If we're talking about a rule-based system, for instance, we would still be relying on data to test whether or not the system is performing as we were hoping. Or maybe it's simply the quality of the data that is used during use of the system. In all of these cases, we are faced with the foundational kind of issue in any kind of computational system. If the input is not is bad quality, the output is always going to be bad quality as well. And one of the problems with the data that we're using for these algorithmic systems is that historically our societies have not lived up to the ideals of an equal kind of society. We have historical bias, and if we simply feeding in that kind of biased data, then we're going to reproduce these systems. So this is what we see, for instance, in the examples here, such as in the middle, we have the example from a couple of years ago. If you typed into a search engine doing image search for CEO, you would basically only get white male elderly men as examples of this as a CEO, with just one or two non-whites, and the only female was Barbie. The problem being that on the one hand, yes, the reality is that the majority of CEOs in the English-speaking world, in the US primarily, which is a dominating driver of the kind of data that you find online, are white males. On the other hand, what the algorithm is doing is it is amplifying the discrepancy. So the real world discrepancy is that it's something like 80% in the US is white male CEOs. The algorithm leads to a result that is more like 95%. So this is a sort of a systematic problem with data. And for instance, there was a very detailed study done looking at computer vision systems and the problems that these systems are revealing when it comes to applying the systems to dark faces and female faces. And this is really simply driven by the fact that a lot of these technologies were developed in research labs where the majority of researchers and majority of students around who are the typical test subjects that are used are white males. And so that has led to these systems to perform quite well on white males, but not well on darker skins, and especially on combinations of dark and female. But the interesting thing that was shown in this study by Joy Bulwini and Timid Gibru was actually that if they present a data set that was specifically tailored to be better distributed across the different types of skin tones and genders, etc., and they train the the face recognition algorithms on this, that these algorithms actually even perform better on white male faces as well, not just, but they dramatically improve their performance on black females, but even on white males, they improve performance because the richer variety in the data sets actually made the algorithms become more attuned to relevant types of features in images. A different aspect, however, beyond the question of the quality of the data set is also the question about what are the criteria that we are building into these algorithms? What is it that how we describe good performance of these systems? So that was really the kind of message that came out of the study that was published by ProPublica, criticizing a algorithmic system for evaluating whether defendants should be up for parole. So this is a system that is actually being used in the criminal justice system in the US, the COMPASS system by North Point. Basically, the company had built the system with the performance criteria of accuracy. So how frequent does the system, if it performs, if it does an evaluation, how frequently does it get it right, basically, is what they were looking at. And they made sure that the system was not biased, so it would be accurate for white defendants or for black defendants at very similar rates. However, what the journalists from Rubrica were looking at was, rather than the accuracy rate, they were looking at the kinds of errors that the system makes when it does make an error. So false positives and false negatives. So if it made an incorrect judgment for a black defendant, would that judgment tend towards being a judgment of these gets incarcerated for a longer time, or a judgment of releasing the defendant? And in that case, they showed a significant bias in the system, that black defendants, when an error was made, would be judged as given a harsher sentence, whereas white defendants would, when an error was made, would be released earlier. However, the subsequent kind of research that went into this after this story was released to really analyze the details of the problem here is where it becomes really interesting, because really what that showed and mathematically proved is that, given the types of underlying statistics of the actual data of criminal behavior, it is fundamentally impossible to make a system that is unbiased across all measures of accuracy or false positive or false negative. So what this really points to is that there needs to be a public discussion, or there needs to be clear justification provided for the choice of what it is that we are going to use as the criteria for optimization of the system, and what it is that we are going to say, this is what we are debiasing the system for. And this is not a choice that a company should be making on its own, or certainly it's not a choice that should be made and not discussed. So, as if any kind of an algorithmic system, the decision-making system, is introduced that has these types of significant impacts on people, there needs to be a public disclosure as to, these are the performance criteria that were used, and this is why we chose this particular definition of fairness for the system. And if you do not agree with this, here are our justifications for it. Let us have a dialogue around this. Now, the problem of algorithmic discrimination or discriminatory kinds of behaviors by technologies is not actually completely new. This is something that goes back to basically the beginning of any kind of technology that has even some way in which it might be able to distinguish between people of different races. For instance, photography. In photography, since it has to deal with different colors and different lightnesses, since even back in the 60s, 70s, the companies that were developing the film for photography had to tune the film to be optimally good for certain kinds of parts of the color spectrum. And because of the primary market that was in the US at the time, it was basically optimized for white skin tones. And this meant that any photo that was taken of people with dark skins was always not really quite right. The color balance was never quite right. And again, this is sort of an issue that was not really discussed. It was a decision that was made for basically business reasons, because the primary market was in a certain kind of place, but it wasn't really disclosed as to what kind of decision making went into this. And it took a very long time for this to even become a factor. And eventually they did actually produce some film that was tuned for other skin tones. A similar problem arose more recently with things like automated soap dispensers that would detect your hand underneath, that they initially didn't function for darker skin tones. So this is an issue that needs to be discussed. It needs to be recognized as a factor so that it can be included in the development process. And for instance, specifically, if we're thinking about exporting a system that was developed in a certain kind of context and brought into a different kind of context, these are the kinds of things that need to be considered in order to make things adjusted to the right, be functional for that context. Another aspect, and this is sort of the final aspect around sort of fundamentals of development of these technologies, is to think about what are the core assumptions that go into a decision making, into even the concept of the types of system that is being built. And so this was a study that had at its foundation a very questionable, kind of ethically questionable point of view, which was, can we use computer vision to identify from somebody's face whether or not they are gay or straight, homosexual or heterosexual? And even from the beginning, we can criticize this system as having taken a very binary point of view regarding sexuality. So in this, the algorithm, because the algorithm was asked to classify according to a binary perspective, there was no possibility for the algorithm to classify somebody as bisexual or something else. It is already building in a certain kind of stereotype of humans. And then, of course, the idea that you're going to use certain kinds of features, and you're simply using the fact that machine learning is effectively complicated statistics. It looks for some kind of correlations. Simply because you can find a correlation doesn't mean that there is a causation. Simply because in this particular data set that you found correlations doesn't mean that that necessarily transfers to a different kind of space if you haven't made sure that your data sets are sufficiently representative, etc. And in the case of this study, for instance, it was actually shown in subsequent that there was a difference in the kind of lighting of the faces that were being categorized as gay or straight. So the point of this slide is really to think about the kinds of prior categorizations that we are imposing on the system even before we are starting to optimize it or train it or whichever methodology we're using. But the way we have formulated the problem is often actually already a introduction of a bias into the problem. Now, one of the reasons that these things have been arising and have really come out into society and become an issue of debate is because the workforce that has been developing these types of technologies, largely coming out of the Silicon Valley area, but frankly, the workforce in Europe isn't much better in its diversity. Is not diverse. We have a huge overrepresentation of white people being the ones that are driving this kind of technology. And this is not to say that they have an intention of building in a biased point of view. However, since their experience of life and etc. is of one certain kind of experience, they will not be aware of the fact that they should be thinking of certain kinds of issues. They don't realize that this is a problem for certain sectors of society. So a lack of diversity within the workforce simply makes it more difficult for them for the people who are developing this to identify where issues might even exist. And so that is one of the reasons why diversity in the workforce is an important factor. And to be aware of a lack of diversity in your workforce, if that is the case, and in that case, to try to make sure that you put in place some kind of compensating methods, like engaging with the stakeholders that are going to be impacted by this kind of technology. Now, these kinds of issues that came up, for instance, in the ProPublica piece, but also in other news articles that have raised issues where an AI system was deployed and then exhibited bias, have driven a large debate around principles, ethics that are necessary to consider when deploying these kinds of AI technologies. And so 2018-19 was really sort of the years of AI principles, where more than 100 AI principles got published. The European Commission had its high-level expert group looking at what are sort of guidance for trustworthy AI. In the academic space, the Asilomar AI principles were published. In the industry space, Microsoft, Google, etc. came out with principles. The OECD published its principles, which have become somewhat of a reference point for a lot of national policymakers, and has been taken up by G20, for instance. And so even simply the proliferation of these AI principles has led to the next question of to what extent is there a coherence between these different ones that are being published. So the Berkman Klein Institute published a very nice study doing a comparison across these, showing that thankfully they do to a large extent line up. So if you are interested, this is a great resource to have a look at. Now, AI is very much at the top of the agenda of many governments when it comes to developing of new regulation. There's somewhat of a race to be the new AI, to establish AI regulation. Sort of whoever comes out with the first clear set of this is how to regulate AI will probably become the template that others will follow. And so we see, for instance, Europe trying to position itself sort of on the back of the success of GDPR. However, others are also pushing forward. Singapore is very much also a leader when it comes to thinking about how to regulate AI. Australia is also doing quite a bit of work in this space. So this is a sort of central area of concern. However, the major bodies working on AI regulation are still very much concentrated in what we might term the global north. It is largely Europe, the US, and then it's global north plus China, really, are the ones that are leading when it comes to driving the discussions around this. I mean, OECD is basically, it's a body of global north. So we have OECD, G20 is somewhat wider, but as I've said, they've basically adopted the work that the OECD has done. UNESCO is really trying to become a more inclusive discussion space that would include also Global South in formulating AI ethics, formulating the direction to go with AI regulation. However, so far, UNESCO is somewhat following behind. They are somewhat not seen as leading the discussion, but rather more as a place where the work that has been done by the European Commission, for instance, or by the OECD is being taken up and then brought in, offered up for discussion by those countries who haven't been involved in the initial formulating of the positions. Council of Europe is also pushing forward. They've launched a work towards establishing a binding requirements on AI regulation for democracy. Again, of course, Council of Europe comes from Europe. So if we are thinking about governance frameworks for AI systems, I mean, so far what we've seen being developed is AI principles, which is nice, but it is not a regulation. It is not a binding kind of thing. The current stage that we're at is that we're sort of at this kind of transition from how do we move from principles to practice? How do we put these kinds of high-level ethical thinking into practical implementations? There is a range of methodologies that one can think of when it comes to governance, starting from the self-governance kinds of modes, such as basically relying on market factors, demand side, supply side kind of factors. If you are putting out a product that is not good, that users and citizens don't agree with, then they will not buy that product. And so through that kind of demand side process, you would hope that products will move into a better kind of more suitable types of service. However, the nature of a lot of these technologies, the requirement for access to data, the network effects where the performance that you get from the product improves simply by having a larger set body of data and other participants in this, often make it that market solutions don't really work. We've seen this very much in the social media space. We also see this in the online platforms, marketplaces. So that moves the governance to things like either company self-regulation or branch self-regulation. So this is basically sort of where we see the principles published by the companies, like Microsoft's AI principles, etc. Branch self-regulation is where industry standards live, and I'll be speaking a bit more about that. And then beyond that, we get to co-regulation or state intervention, which is basically where the state defines these are requirements that need to be met. And that is something that is currently being investigated, gap analysis, to what extent do existing regulations have gaps. But I will focus a bit more now on sort of industry standards and what kind of role can they play. So industry standards, what we're talking about really is things like ISO, IEC, IEEE, etc., national standards bodies. So really this is primarily a place where industry comes together. They are open for participation by academia and by civil society. However, it is primarily driven by industry, and it exists effectively in two kinds of categories. There's the industry, there's the standards that are primarily about compatibility, about technical compatibility between systems, and there's the more process kind of oriented standards, which are things that are related one way or another to quality control, to maintaining quality, to making sure that the way in which the systems are built is up to standard. So this includes things like the ISO 90,000 quality control, but also things like the ISO 12,700, cybersecurity standards, or other things like that. And so in that kind of space, there's now a big push to develop standards around AI and around the procedures that you were following. So the IEEE, for instance, launched in 2017 a set of AI ethics standards, including, for instance, the standard on ethical concerns during system design, the P7000 or 7003 Algorithmic Bias considerations, which is the one that I'm chairing, and I'll go into a little bit more detail. The one that has been published already is the 7010, which is on assessing the impact of autonomous intelligence systems on human well-being. So if we're thinking about standards and how they can contribute to trying to address the issues around bias, so IEEE started this work from the point of view that their motto is really that it should be advancing technology for humanity, not for technology. And as such, trying to really address how is this technology having an impact on people, on the stakeholders in the wide sense of not just those developing and directly using, but also those being impacted by the technology one way or another. So within this standards, this initiative of thinking about the human impacts of this technology, IEEE launched a global initiative on ethics of autonomous intelligence systems. So having a series of standards as well as a document, ethically aligned design, that is thinking more broadly around the kind of questions of how to think about ethics in the context of AI. And so at the core of this is really thinking and recognizing that algorithms in the broad sense, algorithms are socio-technical systems. They do not exist in a vacuum. Rather, they are built by humans within organizations, which are humans, within a social, political, legal, and cultural context, which is all defined by humans and their interactions with each other. So this means that the outcomes of algorithmic decisions have significant impact on real and possibly vulnerable people. So that means really we need to be thinking always not just in the sense of, is this algorithm operating? Is it providing repeatable kinds of results? Is it optimizing this kind of gain function that I had in mind? But we also need to be thinking about, but how is this actually going to impact once it is put out into a real human society used by human organizations? What kinds of, how would different stakeholders within this kind of society react to the operation of this system. So within the algorithmic bias considerations standard, what we're looking at really is to try to minimize unintended, unjustified, and unacceptable kinds of discrepancies in the behavior of the system for one group versus another group. The reason why I define it in these kinds of terms and why we also don't speak about a standard for removing bias is because, in a sense, any system that is performing a task of a selection task, a categorization task, or any kind of task that isn't just a random optimization, a random selection, can be said to be biased. But the point is that it needs to be biased in a way that is functionally appropriate to the type of service that the system is supposed to perform. And so the leading causes really for algorithmic bias, and this strongly connects to sort of all of the issues that I've discussed earlier, is insufficient understanding of the context of use. Do you really understand who the people are that are going to be impacted? Do you understand the culture where the system is being deployed? Do you understand how the people are going to use it themselves? So the people operating it, are they going to use it the way that you think they are? The people that are going to be impacted by it, are they going to interpret the outcomes in the way that you think they will? Does the data set that you've used for training and validating, does this sufficiently represent the context where it's actually being used? Another core question is failure to rigorously map the decision criteria. Have you truly understood all of the different decisions that have gone into building this system? So this is really connects to that question again of the diversity of the workforce. You may simply be building in certain assumptions that you believe are not really a decision. This is just the way the world is from your point of view, simply because you do not realize that from other people's experience of life, that is not necessarily the way that things are. So understanding where have you made decisions, potentially unconscious decisions, in building this system, in deciding what kind of optimization you're following, etc. And then failure to have explicit justification for these criteria. So once you know that you are making a choice, be aware of the kind of choice that you're making and be aware of what your reasoning is behind why you chose this as opposed to another version of fairness, for instance. And so when the questions, therefore, when developing or deploying an algorithmic system need to be who will be affected, what are the decision criteria, how are these criteria justified, and are these justifications acceptable in the context where it's being used? Almost final point. If we reflect back again on the AI principles, for instance, these have also been developed in certain kind of groups of people thinking about issues arising from AI. The majority of these AI principles that have been published from organizations in Europe, in the US, potentially Canada and Australia or something like that, but very much from a particular cultural background kind of perspective. Even the AI principles that have been published by China, if you look at them in detail, they actually reflect more Western values than they do Chinese values to a large extent. They are more like principles for the West to understand where China is coming from, as opposed to principles for China, for Chinese people to be thinking about this, just in the way in which they are formulated. And so this is also a space that needs greater diversity. It needs input from the much broader spectrum of humanity to really raise questions whether or not we are actually prioritizing things in the right kind of way to truly represent the points of view of the globe, as opposed to just a small corner of it. So yes, lack of diversity in standards development also. The majority of standards are being developed by the Global North plus China. This is partially just because of that's where a lot of the industry is that has been developing this kind of technology. But obviously this industry also has vested interests that go into it. They want this kind of technology to be picked up. And they are very much dominated, the whole workspace is very much dominated by men. It is the female voices, there are some, but they are few, and they are challenged more so than male voices because their perspectives are not considered to be sort of the obvious one frequently. And so this is also part of the diversity issue that needs to be addressed. And with that, I thank you very much, and I'd like to open up for questions. Okay. So how are we doing the questions?
Shalini, there is a question in the chat. Can you pick up from?
Yes, thank you so much, sir. My mic was stuck and I was not audible. So we have a lot of questions in the comments. So the first question is that last year Twitter had apologized for their racist image cropping algorithm after like some people pointed it out. So how the trade-off between the fairness and accuracy of the algorithmic systems be decided?
This is an interesting question because of the way it's formulated. Actually, the perspective that there is a trade-off between fairness and accuracy is a particular point of view, to my mind, of looking at accuracy. So it is often just presented as, well, fairness, we have many different ways of thinking about fairness, but accuracy, well, that's obvious. I would argue that that's not true. How you define accuracy is actually something that is also open for definition, because we can define accuracy as saying it is simply maximizing a certain kind of performance on the average over the whole population, or we can say we want to maximize the performance for each subsection of the population. And for instance, that second one would have addressed the kind of issue that Twitter was facing with their performance failing on certain subsections of the population. So is there a trade-off between fairness and accuracy? I think it is a question of integrating fairness into the way in which we define accuracy, and really trying to think about who is it that we are really trying to serve, and what are the issues that are relevant to those different kinds of parties. The challenge that it raises, obviously, is that it complicates matters a bit more. We need to do a bit more questioning, but ultimately it should lead to a better service for a larger part of the population that should end up with better results for everyone.
Please be quiet.
Shalini, you're on mute.
Hello, am I audible?
Yes.
Yeah, please go ahead.
So, you've cut off again.
Am I audible? There's some issue with the mute option in my call right now. I'm sorry about that. So the next question is by Jason, and he is asking, how can these biases be taken advantage of by some group of people in a concerned company?
I'm not 100% sure how to interpret this question as to being taken advantage of. I mean, one one issue with the existence of bias, so, is that it does open up the system to being, in a sense, it's a cybersecurity vulnerability, be it cybersecurity in perhaps a slightly different sense. It's not necessarily the stealing of data, but it is the manipulating of the system. So one of the issues, for instance, with having a data set that isn't sufficiently representative, that isn't sufficiently broad in its core variables that it has in it, is that it may mean that your system, particularly in machine learning kind of an approach, may have gaps where it hasn't been sufficiently trained. You don't actually know what kind of behavior it will exhibit in that kind of a gap. So that means somebody can start probing the system, inserting different versions of input to try and find an area where your system shows instabilities that could potentially lead to a type of performance that they could use to abuse. This has primarily been tested and shown in things like autonomous vehicles and the recognition of things like traffic signs or road markings, because this is a space where the obvious direct safety concerns are something that is immediate, visible. And what they've shown is that you can do minor it seems to the human eye, quite minor changes to the stimulus, to the input, the visual input, that can then trigger the autonomous vehicle's computer vision system to misinterpret the image. But I'm not 100% sure if this is the kind of issue that the question is being referred to.
Sir, the next question is, how can one identify the type of biases in algorithm and mitigate them?
This is an important question, and there is an increasing set of tools that are being developed for this. So various services, IBM, for instance, has a suite, the Fairness 360 suite. Google, as part of their TensorFlow, has also created various test methodologies. Ultimately, what it comes down to is presenting your system with test data that will be able to generate sufficient outcomes so that you can do statistics on that. You can do a statistical analysis to try and identify whether or not this data is showing discrepancies in behavior. So the kinds of test data often are of the type where you would take a representative of, for instance, one person's CV. Let's say if it's a hiring kind of algorithm that we're analyzing, and then you're going to change particular variables within that. For instance, the gender of that person in the CV, and try to observe whether that is going to trigger a change in the outcome. And really, what you need to do is systematically run through the various types of differences that could be possible for the application space that you're looking at, and generating big enough test sets that you can do statistical analysis on that. That's the kind of testing that you can do prior to putting the system into operation. It is also important to have a continuous monitoring going on as the system is in operation, where you do periodic or sort of moving average statistical analysis on the kinds of outcomes that you are producing as a system is in operation, because the context in which you are operating is also not a static space. Society changes over time. The kind of clients that are coming to your particular service will change over time. So you need to maintain observation and monitoring to ensure that the quality doesn't deteriorate over time.
The next question is by Naman, and he's asking, is it really possible to completely eliminate human biases from these automated systems? What's the future like in this aspect?
So my answer to this one is that no, it is not possible to completely eliminate human biases. As long as I've said, these systems are socio-technical, humans are involved in so many aspects of the way in which they're being constructed, of the data that they're receiving, etc., that human biases are always going to creep into the system. But what we are trying to do is we're trying to minimize these biases. We're trying to make sure that we live up to our ideals that we have set as a society, as opposed to our historical failures, by critically looking at the kinds of data that we are using, by critically looking at the types of performance that these systems are showing. And it is a continuous piece of work of updating, maintaining, and improving these systems, basically, which is equally true for human society as a whole anyway. But what we need to do is we need to recognize that simply because we are using an automated decision-making system, it does not get rid of these kinds of biases. These are things that need to continuously be checked for, even if it is an automated decision-making system. At the very least, for instance, we need to continuously think about, are we actually looking at the right kind of variables? The fundamental thing about any automated decision-making system is only that which is measured counts. The question is, are we even measuring the right things? Are we giving the right kind of inputs to this? And that is something that will also change over time, whether we think this is the right kind of factor or not to be taking into account.
So the next question is, since algorithms are also becoming prey to human biases, do the purpose for which they have been put into the system in the first place gets defeated?
Well, that rather depends on what the purpose was. The reality is that for the most part, the way in which algorithmic systems are being deployed is to improve efficiencies. It is to make it easier to scale up a certain kind of task to a broader market without increasing the cost of doing so. As you do so, it becomes more important to make sure that you don't have certain kinds of biases in the system, because you are deploying the same, systematically, the same kind of system to a broader set, which means that if there is some kind of an issue, a bias in the system, it will deploy to everybody. In a sense, in the human approach that we currently have with humans making the decisions, every single human has a certain bias. It may or may not somewhat balance out across the different people that you are using. The other issues, of course, these systems are very narrow-minded in a sense. As I said, they're only that which is measured counts, only that which they've been designed for will be taken into consideration, which means you cannot have the human factor of understanding that, from a human point of view, a life's experience, that in this particular case, maybe we need to make an exception. We need to reevaluate things in a certain kind of way. So this is particularly an issue when we're deploying algorithmic decision-making systems in public sector uses, for instance, in things like evaluating people's access to medical support or those kinds of things, where it has been shown already, as some of these systems have been deployed, that there's been a failure to sufficiently translate the patient's experience of life into the factors that were being measured, which traditionally the human nurse who was doing the evaluations was able to compensate for. But if it's a completely automated system, it couldn't. So these are challenges that we need to continuously work on. But there are definitely things where introducing an algorithmic system helps the operation, the organization, not because the system is superhuman from the point of view of eliminating all bias, but from the point of view of it can automate tasks. It's the same as with any other kinds of automation. What it does is it allows you to scale up more rapidly.
Shalini, sorry to interrupt you in between. I think we missed a question from Som. So if you can take that as well.
Hello. Yeah, sorry about that. So we have a question from Somnath. He's asking, as everyone has started to implement GDPR policy in their organization, so according to you, what do you think how harder it can impact AI?
That really depends on what kind of a application space the AI is focusing on. If it is something that really depends on personal data, so if we're talking about personalization recommendations or something like that, then there is obviously GDPR could limit the kinds of data that you have access to in order to do this kind of personalization. However, GDPR doesn't actually completely block the ability to get this kind of data if you are able to explain to the users why this is a useful thing and the users consent to doing so, then GDPR does not block you to do this. On the other hand, there are a lot of uses where GDPR does not have any limiting factor. If we are talking about business data, for instance, which is increasingly seen as a space that hasn't been exploited sufficiently enough, or if we're talking about more public sector data or those kinds of things, GDPR does not limit these if they're not directly related to personal kind of data, or you can use other methodologies, anonymization or synthetic data, etc., to try to get around issues around this. So yes, GDPR can complicate things to a certain extent if you are dealing with personalization types of approaches, if you are dealing with personal data, but these are not insurmountable problems, and there are lots of areas where GDPR does not have any impact on the kinds of relevant data that you would need for an
AI. So the next question is a follow-up question on the previous, how can one identify the types of biases in algorithm and mitigate them? So Genia is asking how effective these tools like TensorFlow are in mitigating biases.
I fear I can't really give a blanket answer to that. It really depends on the particulars of the application that you're working on and the kinds of data sets that you have access to. Unfortunately, I don't think I can really answer that one.
So we have the last question from Darby. She's asking, can you give us some unique or different examples where algorithmic systems got preyed by human biases in an unexpected manner?
Interesting question. Not sure that I have unique different examples. We've seen a couple of times that algorithmic systems sort of a dynamic where if the system is in a continuous training type of mode and people become aware of the fact that there is such a system there, that they can become prey to deliberate manipulation. It's sort of it triggers people's as, let me see if I can manage to break this thing kind of urge, which we've seen primarily with chatbots, but I think there's also been other cases. I mean, the autonomous vehicles and their computer vision systems is definitely also falls in that kind of space of getting people to want to see how far can I push it until it breaks perspective. There have been issues. I mean, there is a large library basically of cases Algorithm Watch has put together. So this is an NGO in Germany where they've been looking at the use of algorithmic decision making in public sector. Things like in Austria, they were using some algorithmic systems to try and prioritize certain unemployed people who are looking for jobs as to what kind of support they should be getting from the government as job seekers. And they've shown that these systems were biased in a way that they're women looking for jobs were less likely to get good government support following the assessment of this system. The various applications to do with benefits fraud assessments, etc., have shown certain types of bias. It is almost impossible to actually have a largely deployed system where you don't show some form of bias. The question is whether this bias is significant and how it compares to the types of bias that you had if you assessed the data sets from prior to the algorithmic system being deployed. And also, you know, what kind of a response do you get once the kind of bias has been identified? Do people make an effort to actually address this? And really a core question is, have you put in place means for people to raise issues if they say, you know, I've had a decision made about me, which I think is not proper. Is there a way for them to say, I want this to be reevaluated? And is the answer to that question going to be better than, sorry, the computer said it was this and we have no idea why the computer said this? So it's an interesting thing to be looking at. There's quite a number of growing databases that are looking at these kinds of questions and assembling examples, but I probably wouldn't be able to provide a good one right now.
Thank you, sir. We are done right now with all the questions from participants, and we are done with the session on this note. And we would like to thank you for taking out the time from your commitments and being here with us today. And this online mode has enabled us to get you as one of our speakers, and it wouldn't have been possible in an offline setting. So the online mode has definitely been a blessing in disguise for us, and we are very happy to host you in our annual Data Science Summit.
Thank you very much. It's been a pleasure speaking.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.